Greetings everyone, you're watching NeriChem. This is question 5 from the HSC 2018 paper. Cellulose extracted from biomass is able to be used as a raw material in the manufacture of polymers because it is a condensation polymer. So before we start this question, we need to know what cellulose is. So chemically, it is as follows. I will draw the structure. Now, cellulose is a polymer. So we have the square brackets which we use for polymers to denote repeating units. So it's hexagonal. On one corner it has an oxygen. Now on this carbon we have a CH2OH group. Then we have the right hand square bracket, which we put a small n on the right bottom side to denote that it repeats. And then we have an OH group which rises, and we have an OH group which lowers, and on the left hand corner we have the other branch. Now, the empirical formula for cellulose is C6H16O5. However, please do not be confused into thinking that this is the actual molecular formula of cellulose, because it's a long chain, very, very long chain, but that is just the stoichiometry. That means the ratio or the proportion of the atoms with respect to each other. What is cellulose, I hear you screaming from your room? Well, cellulose is the most abundant biopolymer on planet Earth, and it is an important component of plants. It grants plants the rigidity and flexibility, strength of, for example, the stems that we see in the plants that may be in our gardens, for example. Now, cellulose extracted from biomass is able to be used as a raw material because it is a condensation polymer. Okay, first of all, what is a condensation polymer? A condensation reaction is where you have two small molecules, small plus small goes to one big molecule, and usually, although not always, you will get the loss of a small molecule, which is usually water, H2O. In fact, in the case of cellulose, we have a water loss. By the way, this molecule here, the repeating unit, is glucose based. There are many types of glucose depending on the substituents which are on the branches, but because it is a condensation polymer, well, no, there are many condensation polymers, and it is not because of the fact that it is a condensation polymer that we can use it to manufacture other polymers. So it cannot be A. Now, it is a strong and flexible molecule. The idea behind the question is that you take biomass. From the biomass you extract the cellulose, and then you somehow modify the cellulose in order to generate another product, which is again another polymer. Now, when you treat the cellulose in order to become another product, and there may be many products, the properties will change. So the fact that cellulose itself, which is a reactant which will then be chemically changed, is strong and flexible, is slightly irrelevant, because then it's going to have different properties once you chemically change it. So it is true that cellulose is strong and flexible. Anyone who's ever seen wood, for example, will know that it's strong. Anyone who's ever used cotton knows that cellulose is strong. In fact, cotton, I think, has the highest proportion of cellulose of any other material. It's, I think, almost 98%. So again, B is true, but it's not the correct answer. C produces carbon dioxide when burnt. Again, I will return to that principal image that we have. We take biomass, extract cellulose, treat the cellulose to become something else. Why do I care whether cellulose produces carbon dioxide or not when I burn it, if I'm going to turn it into something else? That fact is absolutely true. It is true that you do get carbon dioxide when you burn cellulose because it's carbon based. Pretty much almost all organic molecules will generate carbon dioxide, but it's just not the answer to the question. So D contains a basic carbon chain structure. Now this, of course, is true because we've said that the others cannot be the answer. I'll give you one example of a product which you might derive from cellulose, so that would be CMC. CMC stands for carboxymethylcellulose, and it is generated by mixing under alkaline conditions cellulose and chloroethanoic acid or chloroacetic acid. Ethanoic acid would be the UPAC nomenclature and chloroacetic acid would be the more traditional nomenclature. So of course we know D, it has to be correct. Now CMC, I hear you screaming from your room. What is CMC? Why is it important to me? Why do I care about CMC? Well, if you've ever had dry eyes and you've gone to the pharmacy and asked for some eye drops, you will find that those eye drops will contain a polymer lubricant, which when you put on your eyes makes you blink and not feel so irritated. Now, that polymer is CMC, but it is the sodium salt of CMC. So now you know. And therefore, D is correct because the carbon chain structure, which is in cellulose, can be modified to generate other polymers, such as CMC, which we use on a daily basis. I hope that's been useful to you. Thank you very much for your time. See you next time. Goodbye.